welcome to Rapid Day 2. I'm here with Melanie Lang of FormAlloy, and we're here to find out what's going on with you. So I was maybe just wanting to start off by talk a little bit about how the show's been going for you.
It's been a great show. It's been really busy. We weren't sure exactly what to expect, but we have been, very busy, and it's great to reconnect with everybody and in person again, finally.
Yes, that has been the best part of the 2 days so far. Just seeing everybody. It's been a good turnout, better than I expected, so that was wonderful to see people I haven't seen in 2 years now. So I see a big tagline. It's sitting in front of me, impossible to impossible. And I know you're talking about it, or you spoke about it, and you're also speaking about it at FabTech as well. Can you maybe explain to everyone what that is?
Yeah. So we adopted the new tagline, impossible to impossible. And what that means is that you can utilize additive manufacturing technologies to do things that really aren't possible any other way, either because they're physically not possible or they might be too expensive to do. So it's just a really great way to share stories about what's your impossible to impossible. What have you been able to do with AM that you weren't able to do with other technologies?
Cool. So are any of these parts in front of you AM possible?
They are. In fact, thanks so much for asking.
That's surprising.
Yeah, so we have a couple things here that are unique to additive applications that you really wouldn't be able to do any other way. So, one simple example is, of course, a bimetallic or a gradient part. So this is becoming more and more interesting, especially as people start to trust the process more and standards start to come out for the various processes. Now people are thinking of what's next, and I think this is one of the things that's what's next, and that's, how do you come up with a multi-material approach to achieve what you want to achieve and actually sometimes exceed the performance that you can get with a single material. So this is actually an Inconel material with a copper alloy. It's a GR Cop alloy, which is a copper chromium niobium alloy typically used in aerospace. And it's a great example of how you can control your thermal properties as well as have really good strength in a single part.
Cool, that's awesome. So any other, that's my favorite one right there. I was just telling my daughter about it, so I sent her a picture.
Oh good, okay, awesome.
She's excited.
Yeah, I'll have to watch it in a couple months. It'll actually be on TV. So these are some teeth that we made for one of the BattleBots teams. We were able to support the Ghost Raptor team on this season, and it should come out sometime in the next couple months, but we were able to build these teeth in just a couple of hours. This is aerospace grade aluminum, so it's 6061. And this was the very first build, so we were able to press go and get a great result, and a lot of that has to do with the smart technology we have in our systems that is sort of adjusting the parameters for you and recording those. So the teeth perform very well. That's all I can say. Yeah. You have to watch the latest episode of...
Stay tuned.
That's right. Stay tuned for BattleBots.
No, that's so cool. I mean, I think it's, you've got a number of other cool applications, and I think as we're seeing more and more people come to our space, your technology is one that I think is quite interesting because it can fit into so many different application areas. It's not necessarily just an aerospace technology, and none of them are necessarily, but it's not pigeonholed into anything. You can use it in so many different ways. So
yeah, absolutely.
So what's this thing?
So this is a bracket that we made. This is actually a NavC part, and what I like about this example is that some applications do require finish machining. In this particular application, it's a bracket, so there's not a lot of finishing that's required with it. It's sort of a bracket to hold things in place. So it's more important that it be strong and it can withstand the demands of being on a ship. And this part certainly can do that. So there's a lot of great sort of general manufacturing applications. It doesn't have to be something that flies. It can be, but there's a whole world of applications that we're able to get the cost down a little bit, and it sort of opens the door for other things that can be used.
Yeah, I think it's neat because you're everything from very advanced applications that might be part of a rocket propulsion system to something that you can use and make and take off the machine, and anyone in any shop in the country can take advantage of. So it's so much diversity, but Speaking of diversity,
Yeah.
that's my segue. You're very engaged in a lot of different things. You're very active in the Institute, which we very much appreciate. Sit on our executive committee. And I know another passion of yours is women in 3D printing.
Yes.
And can you talk a little bit about your role in that?
Sure. So yeah, Women in 3D Printing has been an awesome organization. I was a newcomer about 6.5 years ago. I didn't really know anyone in AM in particular. I came out of the aerospace industry, and I was lucky enough to meet the founder of Women in 3D Printing, and she sort of introduced me to the group, and it was really my first opportunity to network, make some mentors, some friends, even find some suppliers and customers, and it's just been an invaluable network. And then this year, I was invited to write a chapter of the Women in 3D Printing book, edited by Stacy Del Vecchio. And it just came out this summer, so I have a couple copies in my booth that I'm giving away. So I know you put your card in there.
I'm looking forward to winning.
Hopefully you'll win, but yeah, it was pretty awesome to be a part of that and be able to share my journey as as I transition from aerospace engineer to entrepreneur. And
that's awesome. Yeah, I think that's another really, we've talked a lot with a number of different people about education and just how do you get into this?
Mm-hmm.
You have, one of the on-ramps where you came from a traditional, engineering field and started your own business,
Mm-hmm.
But there's so many different options where people can get engaged. And I know you've been growing your team, at FormAlloy for the last couple of years in
Mm-hmm.
particular, as you're doing more and more in research and building machines. What kind of folks are you bringing on board lately?
Yeah, well, like you said, it's really interesting because at this point, a lot of people that are in additive, at some point they took a turning point in their career to get an additive, and now there's entire career paths and curriculum that are additive focused. So we're seeing more of those people, which is awesome. So let's keep that going, please. But there's also a lot of people that come out of mechanical, electrical engineers. So we hire a lot of engineers across disciplines. So I would say if it's something that you're interested and passionate about, explore it as a hobbyist and get a little bit familiar with the technology. But you don't have to have a degree in additive manufacturing to have a career with us. In fact, most of them don't, because most of them have taken that turn.
I don't know when I took my turn, but at some point, about 10 years ago, I guess it was left turn. So
yeah.
Well, really appreciate your time. Thanks for spending a couple of minutes with us.
Thanks so much, John.
Appreciate it.
Yeah.
Thanks.